Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When we talk about cloud computing, it can sound like a mysterious buzzword, but at its heart, it is a simple idea. Instead of owning and managing all your own computer equipment, like servers, storage drives, and networking gear, you access these resources over the internet from a provider who maintains them for you. This model is what companies like Amazon Web Services offer. Think of it the way you think about electricity. You don't run your own power plant at home. Instead, you plug into the grid and pay for what you use. Cloud computing applies the same principle to technology, making powerful resources available on demand without upfront investment. One of the defining features of cloud computing is on-demand self-service. This means that users can set up resources like servers or storage space whenever they need them, without waiting for someone else to approve or deliver the equipment. In the past, a business might have waited weeks for new hardware to arrive, but in the cloud, they can create what they need instantly. Imagine walking into a kitchen where you can summon any appliance with the press of a button. That's the convenience cloud brings: resources at your fingertips when you need them, and gone when you don't. Another important principle is broad network access. This means that cloud services are available anywhere there is an internet connection, not tied to a single office or device. Whether you're on a laptop at home, a phone while traveling, or a desktop at work, you can reach the same cloud resources. This accessibility transforms how people and organizations operate. Remote workers can collaborate as if they were in the same building. Customers can access services around the clock. It's the difference between storing files in a locked drawer and storing them in a secure online space that can be safely reached from anywhere. Resource pooling is another concept you'll often hear, and it connects to the idea of multi-tenancy. Imagine a large apartment building where many tenants live under one roof but have their own private units. In the cloud, computing resources are pooled together in a shared environment, and providers carefully partition them so that multiple customers can use the same infrastructure securely and efficiently. This design allows providers like AWS to serve thousands of organizations at once, balancing demand across their data centers. Customers don't have to worry about what hardware their systems run on. The cloud ensures they get what they need without interfering with anyone else. A key benefit of this pooling is rapid elasticity. This is the ability for resources to expand or shrink quickly as demand changes. Think of a balloon that can grow larger when you blow air into it and shrink back down when you let air out. For a business, this means they can handle sudden spikes in traffic, such as an online store during holiday sales, without needing to buy permanent hardware for rare events. When the rush ends, they can scale back down, saving money. Elasticity ensures organizations always have the right amount of resources, no more and no less. Measured service, often described as pay-as-you-go, makes the cloud financially appealing. Just as you pay for utilities like water or electricity based on usage, cloud customers pay only for what they consume. If you store a small amount of data or run a small server for a few hours, you're billed for exactly that, not for an entire data center. This model removes the guesswork of large upfront spending and allows businesses to experiment more freely. They can try new ideas without financial risk because they only pay for what they use and can stop any time if the service is no longer needed. To appreciate these principles, it helps to compare them with traditional IT models. In the old approach, companies purchased physical servers, installed them in dedicated rooms, and maintained them with cooling systems, electricity, and staff. If demand suddenly increased, they had to buy more servers, which took time and money. If demand dropped, they were stuck with unused equipment. This model lacked flexibility and often led to wasted resources. Cloud computing reverses that equation. It offers flexibility, scalability, and efficiency that traditional models could not match, making it the natural next step in the evolution of computing. The benefits of cloud computing extend beyond businesses to individuals as well. Everyday services like email, online photo storage, and streaming platforms are all powered by the cloud. Instead of worrying about running out of storage on your computer, you can store photos in a cloud service that grows with your needs. Students can use cloud-based tools for collaboration on projects. Even gamers are experiencing the cloud through online gaming platforms that stream entire games without requiring expensive consoles. The impact is everywhere, often invisible, but deeply integrated into daily life. Private cloud, by contrast, is dedicated to a single organization. It may still use cloud technologies like virtualization and automation, but it runs in a controlled environment, either in a company's own data center or on hardware reserved just for them. Some industries with strict regulations, such as finance or healthcare, prefer private clouds because they want more control over data and compliance. The trade-off is higher cost and less flexibility compared to the public cloud. You can think of it like owning a private vehicle rather than using public transportation. You have control, but you also carry the responsibilities and expenses. Hybrid cloud blends the best of both public and private models. An organization might keep sensitive data in a private cloud while using the public cloud for less sensitive workloads or for scaling quickly during busy times. It's like having both a car and access to public transit. You choose whichever makes the most sense for the situation. Hybrid models are common because they allow businesses to balance control, cost, and flexibility. This approach acknowledges that one size does not fit all, and organizations often need a mix of strategies to meet their needs. Multi-cloud strategies go one step further by using services from more than one cloud provider. A company might use AWS for storage, Microsoft Azure for certain analytics, and Google Cloud for specialized machine learning. This prevents over-reliance on a single provider and allows organizations to pick the best tool for each job. However, multi-cloud adds complexity since teams must manage different platforms. Think of it like speaking multiple languages, useful for communicating with diverse groups, but requiring extra effort to stay fluent. For large enterprises, the flexibility of multi-cloud often outweighs the challenges. Finally, we should place AWS within the bigger story of cloud evolution. When AWS launched in 2006, it was one of the first to offer cloud infrastructure at scale. Since then, it has grown into the leading provider, with the largest global footprint and the widest range of services. AWS set many of the standards we now associate with cloud computing: on-demand access, broad service variety, and global infrastructure. Its innovations shaped not only how companies use technology, but also how entire industries approach growth and change. Understanding AWS is essential because it is both a pioneer and a current leader in the cloud era. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. One of the greatest advantages of the cloud is agility. Agility means being able to move quickly and adapt without being slowed down by heavy investments or complex processes. In practical terms, this means businesses can test new ideas faster, release updates to customers more often, and pivot if a strategy is not working. Innovation thrives in this environment because experimenting costs little and failures are not catastrophic. Imagine a painter who has unlimited canvas and paint at very low cost. They would be more likely to try bold new strokes. In the same way, the cloud encourages organizations to innovate because the barriers to entry are so much lower. Cost effectiveness is another powerful advantage, often discussed in terms of total cost of ownership. In traditional IT, companies had to factor in not just the cost of equipment, but also electricity, cooling, real estate, and the staff to maintain everything. The cloud shifts these costs to the provider, who achieves economies of scale by serving thousands of customers at once. This means customers pay less overall for the same capabilities. It also changes costs from fixed to variable. Instead of making huge upfront purchases, businesses pay only for what they use each month. This predictable, usage-based model helps companies manage budgets more effectively. Global reach is a defining characteristic of providers like AWS. Their infrastructure is divided into regions and availability zones around the world. Regions are geographic areas, such as North America or Asia Pacific, while availability zones are separate data centers within those regions. This design ensures both proximity to users and fault tolerance. For example, a video streaming company can place servers closer to its viewers in Europe to reduce buffering, while also backing up content in another availability zone to protect against outages. This worldwide network makes it possible for even small companies to operate at a global scale, reaching customers wherever they are. An important concept in understanding cloud computing is the shared responsibility model. In this model, the provider and the customer each have roles to play in keeping systems secure and reliable. AWS is responsible for the security of the cloud, which includes maintaining data centers, physical equipment, and the core infrastructure. Customers, on the other hand, are responsible for security in the cloud. This means they must properly configure their services, manage user access, and protect data. The model ensures clarity. AWS provides the tools and foundation, but customers must use them correctly. This division of responsibility is central to understanding how cloud security works. Reliability and fault tolerance are critical features that distinguish the cloud from older computing models. Reliability means services stay available and consistent over time, while fault tolerance means the system continues functioning even if part of it fails. In AWS, this is achieved by distributing resources across multiple availability zones. If one zone experiences a problem, workloads can shift to another without disruption. Think of it like a highway with multiple lanes. If one lane is blocked, traffic can continue moving through the others. This design provides peace of mind to businesses, knowing that their critical systems are less likely to suffer major downtime. When discussing the cloud, many people naturally worry about security. Providers like AWS take this concern seriously, investing heavily in both physical and digital defenses. Their data centers are protected by security guards, biometric access controls, and surveillance systems. On the digital side, AWS offers encryption, monitoring tools, and compliance certifications that meet global standards. While no system is perfectly secure, most organizations find that the cloud actually improves their security posture compared to managing systems on their own. By using the cloud, they can access advanced protections that would otherwise be too costly or complex to implement independently. Cloud computing is not an abstract concept. Its value is seen clearly in customer use cases across industries. In healthcare, providers use the cloud to store patient records securely and share them quickly between hospitals. In retail, companies use it to run online stores that scale up during busy shopping seasons. In entertainment, streaming services rely on the cloud to deliver movies and music instantly to millions of users. Even government agencies use the cloud to manage public services more efficiently. These examples show that the cloud is not just a technology trend. It is a practical tool with wide-ranging impact. Despite its advantages, some barriers to cloud adoption remain. Organizations may worry about data security, losing control, or the complexity of migrating from old systems. Cost can also be a concern if usage is not monitored carefully, since pay-as-you-go can lead to surprises without proper oversight. In addition, cultural resistance within organizations can slow adoption. Employees may fear change or lack the necessary skills. Overcoming these barriers requires clear education, careful planning, and often starting with smaller projects that demonstrate value before moving larger workloads. Recognizing these challenges helps organizations adopt cloud services more confidently. There are also myths and misconceptions about the cloud. One common myth is that data in the cloud is less secure than data stored locally. In reality, security depends more on how systems are managed than on where they are located. Another misconception is that the cloud is always cheaper. While it can save money, costs must be monitored and optimized to ensure true savings. Some believe the cloud is only for large companies, but small businesses and even individuals benefit from cloud services every day. Clearing up these misunderstandings is essential for making informed decisions about adoption. Cloud computing is a central driver of digital transformation. Digital transformation refers to how organizations use technology to fundamentally improve their operations and customer experiences. The cloud enables this by providing tools that make data more accessible, applications more scalable, and innovation faster. For example, a bank might use the cloud to launch a mobile app that allows customers to manage accounts in real time. A manufacturing company might use cloud-based analytics to improve efficiency. These changes go beyond technology. They reshape business models and customer expectations, with the cloud as the foundation. For companies preparing cloud-first strategies, the message is clear: prioritize cloud solutions whenever possible. Instead of asking, can we move this to the cloud, the question becomes, why wouldn't we move this to the cloud? This shift reflects the advantages of agility, scalability, and cost-effectiveness. A cloud-first approach encourages businesses to innovate rapidly while still maintaining security and compliance. It does not mean everything must be in the cloud immediately, but it does set the expectation that cloud solutions will be the default choice unless there is a strong reason otherwise. This mindset is becoming increasingly common worldwide. All of these fundamentals connect directly to the AWS Certified Cloud Practitioner exam objectives. The exam is not about memorizing obscure technical details, but about demonstrating an understanding of these core principles. You are expected to explain cloud models, describe advantages like elasticity and cost-effectiveness, and understand basic responsibilities for security and compliance. Mastering these ideas not only prepares you for the exam, but also gives you confidence when discussing cloud strategies in real-world settings. The exam serves as both a test of knowledge and a validation of your ability to speak the language of cloud computing. As we close this episode, remember that cloud fundamentals are both the foundation of the exam and the foundation of a career in technology. These principles: on-demand service, global reach, shared responsibility, security, and cost-effectiveness shape the modern digital world. Whether you are pursuing a technical path or a business role, understanding them will give you an edge. Think of this as laying the first bricks in a strong building. With each episode, we'll add more layers, but the structure depends on these fundamentals. With a clear grasp of cloud basics, you are well on your way to success in AWS and beyond. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.